Now let's go with the pin diagram now. Okay, basically hardware configuration. With that, after that we'll jump to software. Okay, that this is the last part of the whiteboard. Like one for the brainstorming, I use the whiteboard. Second thing will be the that part. Yeah, pin diagrams. Once I explain you the circuitry, basic circuitry. Okay, I will not explain the actual pin configuration. Basic circuitry I am going to explain. With that, we can just hop into making the thing. Yeah. So let's go. So basically, what we need is I guess. Yeah. So we need is a simple as that we need a microcontroller. Yeah? So ESP12V. That's our microcontroller. Yeah. Now ESP12V with the I2C bus we can use gyro. Yeah, we can use gyro. We need six pins for the motor controller. Motor driver, 6 pins for motor driver. Now, one thing to make sure here is motor driver part, like 6 pin out of 6 pins, 2 pins should be PWM pins. Yeah. So PWM pins. Why? Because PWM pins requires what I call because the speed controlling of the motor driver requires PWM pins. Okay. With that, ESP12V, I to see for the gyro, motor drivers with this part. Okay. So motors are controlled. Yeah. We need one pin for one any random pin for what I call um servo. Sorry. Yeah, so for servo, we'll use one pin, okay, any random pin. It should be digital, and rest of the 4 pins also should be digital. This pin should be digital, this should be digital, yeah, digital, uh, yeah, servo, digital, 4 pins, digital, perfect. Gyro, done. Gyro require 2 pins, okay, with that, 1, 4, 2, okay, done, and 2 more, done. Okay, we are left with a few pins. Now, for that, what we can do here is we can use, okay, for the context, while I was like researching about this thing. So we don't need, I guess, we don't need any analog pin in our project. So for the what we can do is for the proximity sensors, I was planning to use right and left. I was planning to use that thing. What do we call them? IR sensor, yeah. So IR sensor is just a digital output. So for the digital output, we don't need anything. What is the digital output? It's basically just the voltage up down, a lower high. Okay. So analog can also detect it. So I can use that analog pin for one IR. Okay, one IR can be done with this and one digital. So A is 0 and digital pin for second IR. Yeah, second IR. Yeah, second IR digital, first IR analog. Yeah, we can do that. Major requirement, we require a bridge pin, what do you call uh, resistor bridge. Okay, resistor bridge. Basically, resistor bridge will convert its voltage. So the IR sensor will give the signal in 3 volts, and analog pin is just able to detect till 1 volt. So I will use a resistor bridge to give it 1 volt from the IR. Okay, yeah, that will work. Yeah, with that, this is part done. So, and we also need one ultrasonic, yeah, for the front part, right? So, wait, but pin one thing. Okay, so I know the how many pins are in 12V. So we are short with the one pin, like we don't have one pin. Okay. Uh, so what we can do here is we need 2 pins for an ultrasonic sensor, and we have only one pin. So I would say, as you remember, when I was drawing the board, I have placed the IR in this position, in this path, right? And this was my plan to make an ultrasonic sensor here. But instead, what we can do is, so IR basically can now detect this portion, this part, and this part. So it is detecting forward also, as well as left. It is detecting forward as well as right. So IR can do this much area, right? So this much is enough to not not make it fall off the table. So we don't need ultrasonic. Yeah. So ultrasonic is not required here. Fine. Yeah. So in the safe, I guess. Yeah. So one pin we have. Still have one pin. I don't know what purpose I can use it for, but yeah, this much is enough. And this is the whole circuit diagram. Circuit analyze what things we require for. Yeah. Not even a pin diagram. Pin diagram, I will just draw it and share, I guess, in a GitHub. Something like that. Yeah. Rest, I don't think so. I'm left with anything, but let's see. One pin I have. I was planning to use an encoder, but we are out of pins. So yeah, that also a thing. Yeah, I would suggest use a good processor. Microprocessor. You can go with the 32, I guess, because it has a lot of more pins. But to me, ESP12 is very cheap, like 150 rupees. So I go with this thing. Yeah, sometimes you need to go cheap. Basically, I have this component, so I'm going with this component. You can go with a good ESP, so that you can any day can add extra components like what do you call that? Yeah, magnetic encoders for the distance travel. Okay. So basically, you can track how much distance the bot has traveled using the magnetic encoders on the wheel, and it can track how much revolution a wheel have made. So you can track how much it rotated to reach a certain location. Yeah. With that said, we have that much, this and this, and lastly, okay, this is done. This part is done, right? So yeah, this much is enough. Now what we can do is we also need don't just need this one. This is a processing and sensor units and all that things. Okay. With that, we also need a power management system. So what we will go with is two batteries. Okay. I mean, yeah, 2s lithium-ion cells. Lithium-ion cells. Okay. We have this battery pack. We need a BMS over here. Or we need a BMS to maintain its charge and discharge. So any output will be required from the BMS only. Okay. So input will be also from BMS only. Yeah. So input we need a charging point. So we need a charging point. Okay. Let's make it a charging point. Yeah, charging point. And here is the output. Okay. So charging point standard is 12 volts. So 12 volt is standard. So I will attach one more thing over here. This one more device. This will be a buck converter. Okay, buck converter. Basically, it will change the 12 volts into 8.4 volts for the 2S battery configuration. Yes. So we can just go with the 12 volt to 8.4 volts. With so buck converter. Yeah. Charging point, buck converter goes into BMS. BMS then provides the output voltage. Now BMS will provide, and now from the BMS I will require two things, one over here and one over here. This is also a buck converter. This will provide 6 volt as output, 8.4 as input, 6 volt as output, 6 volts, 8.4 volts. Yeah. What I'm doing over here is, so basically I'm going to use 8.4 volts to power my motor driver. Okay, motor driver L298. Yeah, L298. Yeah, this will be powered by this. Fun fact, L298 can also provide 5 volts, but okay, nevertheless. And the 6 volt I am going to use for the servo part. Servo. Yeah, great. So 6 volts for servo, 8.4 volts for L298. With that said, what I can also do here is, this is fine. From this, I can also make it do something like a 6 volts will go there, 8.4 6 volts. And from this 6 volt, I can use a 3.3 volt regulator to power my ESP and all the sensors. Yeah, ESP and sensors. Yeah, basically I have sensor and ESP only. Yeah. So with this, everything is powered, I guess. Lithium-ion cells, charging, go to BMS. BMS provide the battery to buck converter and alternate. Buck converter converted to 6 volt. 6 volt goes into servos. Servos requires 6 volt. Now from the 6 volt, I can use a regulator of 3.3 volt and provide that to ESPN sensors. And with that, our power configuration done. Yeah, this is our power configuration. Great, done. So anything else required now? Nothing. I guess we can just jump into building. I guess. Yep. This was the electronics part. Yeah, great. Yeah, great. This is the yeah, thank you, I guess. Bye bye.